So in this section of the playlist, we're going to be talking about vectors. Now, vectors are a very important quantity to learn about in physics, or kind of quantity, because they pop up all over the place, and you should be familiar with vector stuff in future chapters. So after this, you should know the difference between a scalar and a vector, how to represent vectors on this thing called the IJ plane, that we'll get into when we get to it, how to add and subtract vectors, how to convert between polar and component form, and how to multiply the dot product. Now, as always, a lot of these might sound incredibly alien. However, if you have finished this playlist, you should probably go back and see if you understand everything that's on this particular slide. So, the first thing we're going to start off with is how to differentiate different kinds of units, because in physics we have two different unit quantities. We have the scalar and the vector. So scalars are represented by just a number, so whether it be length, circumference, and speed. One key thing about scalar quantities is that they're always greater than 0. So length is always greater than 0, circumference is greater than 0, and speed is considered greater than 0. And we'll get onto why that is. Because when we get into vectors here, they require a number, which is known as a magnitude, and a direction, known as an angle. Sometimes it can be called a bearing. But magnitude and direction is mostly the way people say, or how people describe a vector. Some examples are displacement, velocity, and acceleration. The key difference here is that velocity is a vector and speed is a scalar. We'll come across later this important sentence. Which can be written in a couple of different ways, but speed is the modulus or magnitude of the acceleration, or of the speed is the magnitude of the velocity, rather. It is a key phrase to know, just to kind of differentiate between the scalar and the vector units.